We're going to talk about the graphs of f, f prime, and f double prime and how that relates to the graph of f of x. So we're going to let these graphs be the graphs of f prime of x. And what I want to know about f of x is, where is f of x increasing, where is f of x decreasing, and does f of x have any maxes or mins? So on this first graph, if we're thinking about f of x, but we're looking at f prime of x, we're thinking about where this graph is above and below the x-axis, because what we know about f of x increasing means that f prime of x is positive. Well, because this is a graph of f prime of x is positive there and there. We're going to let these numbers here be negative 2 and 2. So f of x is increasing from negative infinity to negative 2 and 0 to 2. Likewise, that means f of x is decreasing from negative 2 to 0 and 2 to infinity, because that's the part that's below the x-axis. So any part where f prime of x changes sign, which is there, there, and there, are places where there are maxes and mins. You have to figure out if it goes above the x-axis to below or below the x-axis to above. And so in this case, in the first graph, there's going to be a maximum at x equals negative 2 and x equals positive 2, because the f prime of x is changing from positive to negative, meaning that f of x is increasing to decreasing. There's going to be a minimum at x equals 0. Okay, so I made the graphs just a little bit bigger just so that it would be easier to see. This graph, we're going to let this be maybe negative 4, and this graph be 3. And then obviously there's 0 at the middle. Alright, so if this graph is f prime of x, what we know about f of x is increasing where this graph is above the x-axis. This graph is above the x-axis from negative 4 to 0. And also from 3 to infinity, because that's there and there. This graph is below the x-axis from negative infinity to negative 4, and also 0 to 3. So that would be where f of x would be decreasing. I'm going to look at these places here where everything changes. In this particular graph, it looks like that f of x has a maximum at x equals 0, because f prime of x is changing from positive to negative, and that there is also a minimum at x equals negative 4 and 3, because f prime of x is changing from negative to positive, or decreasing to increasing if that helps you. Okay, let's look at this next graph here at the bottom. Notice this graph looks like there's an asymptote on this one, so it doesn't go above the y-axis. What that means is that f of x is always decreasing. Because f of x is always decreasing, there is no max and no min. Also, if you want to look at it this way, the graph doesn't cross the x-axis, so it never changes. And again, this graph we're looking at is f prime of x. You have to keep in mind which graph you're looking at to be able to answer the questions that it asks you. Okay, we're going to let this graph here be, sorry about that. F prime of x again. This will be our last f prime of x before we talk about f double prime of x. I noticed that the graph is above the x-axis all there, below the x-axis here. So that tells me that f of x is increasing. Okay, we need some values again. Let's let this be -4 and this be +4. From negative infinity, no, we were at -4 to 4. You could say -4 to 0 and 0 to 4 if you wanted. F of x is decreasing from negative infinity to -4 and 4 to infinity, because that's where f prime of x is below the x-axis. In this case, there's only one max and one min. F of x has a max at x equals 4, and it has a min at x equals -4. And the way that I can tell that is because remember that the graph is going from negative to positive, or decreasing to increasing, so that makes that be a min, and then increasing to decreasing makes that be a max. Here at 0, even though the derivative is 0 at 0, that does not give us a max or a min. It just really doesn't give us anything, so we don't talk about what's going on at 0. Alright, so we're going to let this graph be f double prime of x. What we know about f double prime of x is that we can figure out things about f of x, about concavity and points of inflection. So what we're going to be looking for here is where f of x is concave up, concave down, and where it has points of inflection. We do something similar to what we did on f prime of x as far as looking at above and below the x-axis. Because I know that f of x is concave up where f double prime is positive, and concave down. We're going to let this graph be f double prime of x. And what I can tell about f of x from f double prime of x is where f of x is concave up, where f of x is concave down, and where f of x has any points of inflection. Notice that this graph is below the x-axis until I get to b. And since it's below the x-axis until I get to b, that means that f of x is concave down from negative infinity to b, and concave up from b to infinity, because f double prime of x is positive from b to infinity. That means that there's a point of inflection at x equals b, and that is the only place where concavity changes, so that's the only point of inflection. Okay, I'm going to draw a new graph here. So I'm going to let maybe the graph look like this. This will let that be 0, and this will let that be 4. Again, this is f double prime of x. If you'll notice, this graph is above the x-axis until I get to 4. So that would be where f of x is concave up. And then f of x would be concave down from 4 to infinity, because that is where this graph is below the x-axis. And there's only one point of inflection, and it's at x equals 4. Notice concavity does not change right there, even though the derivative, second derivative is 0 there. It's not going through the x-axis, so that is not a point of inflection. We're going to let this graph be f of x, and just to make sure that we understand all the terminology, I want to make sure that you can see it in terms of f of x. We're going to say there is 0. We're going to say this value up here is at 3. We're going to say that there's a place here sort of in the middle at 2. We're going to let this 0 here be at 4, and I think that's all the information we need. Alright, we're going to figure out where f of x is increasing, decreasing, where it has max, mins. We're going to look at concavity, and we're also going to look at points of inflection. Alright, so this time we actually look at the slope to figure out increasing and decreasing. This graph has a positive slope until I get to 3. So f of x is increasing from negative infinity to 3. And that's just the normal looking at the slope part of it. Decreasing, this graph would be decreasing from 3 to infinity. And I can look at it and tell that there would be a maximum at x equals 3. It's also the place where increasing and decreasing changes. And there's no minimum. Alright, so with concavity, I'm going to sort of draw it out because I think it's easier. I can tell that this graph is concave down at first. Then it changes, and then it's concave down again. So it looks like this graph is concave down from negative infinity to 0, and then from 2 to infinity. The graph is concave up from 0 to 2. And then what that means is that there's two points of inflection. There's a point of inflection at 0 and a point of inflection at 2. And when you highlight that, I think it's easier for you to see the concavity. It's also easier for you to see the points of inflection. We'll be looking at some more graphs in class related to f of x, f prime of x, and f double prime of x.